Hello, this is Randy Stafford. I'm the product manager for Oracle Coherence, and I'd like to give you an introduction to our new release 14.1.1. Let me start by reviewing the themes that we work towards in every one of our Coherence releases. We deliver both in core product and in open source. 14.1.1 is a numbered Oracle Fusion middleware release, part of the core product. So in every release of Coherence, we are trying to simplify cloud-native development and enable operational excellence in the cloud. We are also trying to facilitate microservices architectures with modular, configurable, versioned microservices and polyglot programming on both the client and the grid side of the architecture. And lastly, we are always trying to enhance the proven core product that is Coherence to increase the number of use cases and architecture paradigms we support, and to always increase the reliability, availability, scalability, and performance of our software. And you'll see these themes in the features that are in 14.1.1. So here's the list of the new features with a detailed slide following on each one. We have a messaging implementation called Topics. We've implemented support for distributed tracing in Coherence, and we are running on the Oracle VM on the grid side, optionally. And we have an asynchronous mode to our persistence feature now, and we certify on JDK 11 with 14.1.1. So Topics is a messaging implementation. It's not intended to be a JMS compatible implementation, but it has all of the familiar features in a messaging system. Channels or destinations, we call them named topics, publishers and receivers. And we have a patent on the scalability of this implementation. We distribute the topics and their contents across the data grid. And this gives us very high throughput. In the bar chart here, you can see that we were hitting 300,000 message receives per second in the orange bar scenario, which was a unique topic for every publisher and receiver pair. And that was with a Coherence cluster of only 3 cache servers. So the throughput increases as you scale out the cluster size and get more cache servers and more machines involved. We do grid-side content filtering and transformation, if desired, for receivers. And the intent of Topics is if you are already using Coherence for distributed caching or grid computing in your application and you need a messaging system, this allows you to leverage Topics without introducing another dependency into your architecture. Next, in 14.1.1, we've implemented distributed tracing. This allows requests coming into Coherence to be broken down for diagnostic purposes, understanding how response time is composed. We trace spans on the primary owner of a cache entry and the backup owner and our persistence layer and on our client. And this is done through the Open Tracing API. Our spans can be part of larger scope spans in applications that call into Coherence. We are agnostic to the collector that is used. We work with but don't require Zipkin and Jaeger. And this can be switched on at runtime with very little performance overhead. The Graal VM support that we've implemented allows you to code on the grid side of the architecture in any language supported by the Graal VM. For example, JavaScript. We have documentation on how to write grid-side code in JavaScript. This also allows you to do things like embedding Coherence in non-Java applications, for example, in a Node.js process. And all of these new features in 14.1.1 work with the Docker and Kubernetes ecosystem that we've been supporting since 2016 in the case of Docker. So you can run Coherence clusters in Docker containers and use Kubernetes to orchestrate them. We leverage the Grafana and Prometheus and Elasticstack components in this ecosystem to monitor and manage Coherence clusters. We can scale out using Kubernetes, using the kubectl command line, and we can scale back in safely with our operator so we don't kill the primary and backup owner at the same time. You can deploy custom server-side code with our operator, and we spread cache contents across Kubernetes zones for high availability. And if you're using Coherence's persistence feature, we leverage persistent volume claims in Kubernetes. And we have our own custom resource definition in our operator that allows you to define the roles in a cluster: cache servers, proxy servers, management nodes, etc., and flexibly map ports and expose services. Here are a number of resources you can consult to learn more about Coherence 14.1.1. We have a community website, coherence.java.net. We have a GitHub site for our operator and the rest of our open source projects in the Coherence community. And of course, on Oracle Technology Network or oracle.com, we have a landing page for Coherence with links to downloads, documentation, and other resources. We have a couple of blogs about Coherence. There's one on blogs.oracle.com, and there's one by a developer of ours in Australia. We have public Slack channels, a workspace called oraclecoherence.slack.com. We have a general channel, and we have a specific channel for our operator. And finally, we have a presence on a variety of social media sites. YouTube, we have a pretty rich YouTube channel full of videos about Coherence, which is where this video will end up. And we have a Twitter account, we have a Facebook page, and we have a LinkedIn group for Coherence. So with that, I'd like to say thank you, and I wish you success with your projects, and hope you'll take a look at 14.1.1. Thank you.